Welcome back. In this video, we will discuss the wait group from the sync package. So why do we need the wait group? We will discuss that in few minutes. So before we continue on that one, before we continue the discussion, I want you to think about outcome of this program. The expected outcome could be something like it cannot be consistent. Example like a value. Let's think about the scenario 1 where the count can be increased. The go routine will be created. Count can be increased. It can be 1. If it is 1, then it will be printed here. If it is, and then program will be terminated. That's one scenario. Second scenario, count go routine is being created, but before the go routine updates the count variable, count if condition is being executed and value is being printed as a 0. And the third scenario could be like the go routine is being initiated, condition is being checked, before the print function executes, go routine will update the value and value 1 will be printed. So these are the three possible outcome of the execution. So since these are not the output, expected output is not being generated consistently, in such a situation we should use wait group. Wait group ensures the race condition does not happen. Let's see what is a wait group and race conditions are. Race conditions occur when the order of execution is not guaranteed. We have seen three different scenarios. Concurrent programs does not execute in the order they are coded. Go provides fork and join mechanism for the go routine. That is, the main program will be run, go routine will be created, and once the execution of the go routine is completed, it will join back to the main program or main group. So let's see what is that. Sync has wait group option, that is wg is the variable. Here we are creating the variable wg of sync.waitgroup. Before creating the subroutine, we are initiating waitgroup.add, and the value 1 is nothing but how many subroutines we have created. Then we are creating the subroutine. Inside the subroutine, we are using the defer keyword wg.done. That is, we are explicitly mentioning that once the execution of go routine is completed, execute the wg waitgroup.done, which decrements the count by 1. And then after completion of this, wg.wait is been added, which checks what is the current count. It explicitly halts the execution of main routine. So and that helps us to get the deterministic output. Let's go back to the code and implement it. So we will create a variable wg of sync.waitgroup. Now we will use wg dot add increment the counter by 1. Now we will mention defer wg dot done. So we are explicitly mentioning that the function has completed. Now here we are going to add wg dot wait, which indicates that the main routine should wait for the execution of thread. Let's go and execute our code. So value written by here is 1. Value written is 1, that is else loop, that is correct. So No matter how many times we execute the code, it will be 1. What happens if I remove whatever the code we have added here? Let's try to execute the program. It doesn't return the value 1, so it is unexpected outcome.